Hello, Algebra Tours. Today we're going to be talking about a new method called completing the square. And while you watch this video, you do not have to take notes except for there's one slide that you're going to have to write inside your notebook. And on that slide is going to be a picture of a pencil in the top right-hand corner, okay? So you do not need to write anything down unless you see that one slide that has a pencil in the top right hand corner. Then you're going to have to write it down in your notebook. All right, so with that, we're going to get started by talking about completing the square or finding C to solve by completing the square. So far in Algebra 2, we've talked about how we can factor and solve. So like in this number one problem, what we've done in the past is we set up two sets of parentheses and we said the first thing times the first thing has to get back to x squared. So it's x times x got me back to x squared. Then the last thing times the last thing has to multiply to 20, but it also has to add to 8. So 20 has factors of 20 and 1, 4 and 5, 10 and 2. So most likely we'd want 10 and 2, where 10 is negative and 2 is positive. So then when we multiply it back out, we would get x squared minus 8x minus 20. And then we would set each factor equal to 0, getting x is equal to 10. And if we set the other factor equal to 0, we get x is equal to negative 2. So we learned in this unit, that was the first thing we learned, was all these different ways to factor and solve. Most recently, we've learned how to solve by getting x squared alone and then taking the square root. So we've added 5 to the other side in this example. We took x squared, equaled it to 7 plus 5 would be 12. Take the square root of both sides, then we're going to get x is equal to plus or minus. If you break down 12 into the square root of 4 and the square root of 3, it'd be x is equal to plus or minus 2 roots of 3. So my question to you is, we know how to factor and solve. We know how to get x squared alone and take the square root. But what happens if we have something like this, x squared plus 4x plus 1 equal to 0, but there's no way I can get x squared alone, and there's no way that I can factor this guy, because if I set up my two sets of parentheses and I have x and x, well, the only thing that's ever going to multiply back to get to 1 is 1 and 1, but there's no way that 1 plus 1 is ever going to get to 4x. So what are we going to do when we have these types of situations? Well, that's where completing the square comes in. So we're going to have to try something else or something new, because factoring and solving by taking the square root won't work in this example. So this whole video is going to be talking about how to start completing the square, and that's going to be finding C, and we'll talk about what that means. So for the first couple slides, I keep saying that our new method that we're going to use is completing the square. Well, what do I mean when I say we need to complete the square? You guys, every single quadratic equation or every single equation that has an x squared term in it can be in its generic form written like this. Ax squared plus bx plus c is equal to 0. Or they're saying the generic form at most, the most amount of terms you can have when you have a degree of 2 or a power of 2 in this quadratic equation is 3. So we could have an x squared term, we could have a regular x term, and we could have a number, and then of course because it's an equation we're equaling it to 0. So every single time we talk about quadratics, this is the generic form of a quadratic, okay? So when we complete the square, the first step in completing the square is to find a value C that's going to help us complete the square. And this whole video is going to be talking about finding C and what that means when we say complete the square. So geometrically, what we're talking about when we say complete the square, we're talking about an actual shape that's a square that has the same length and width, and we're going to call that length and width x. Okay, so if we look at, if we look at this first example, we have an expression that says x squared plus 4x plus some c, or plus some number back to our generic form, is our quadratic. So we need to figure out what this c is to complete the square. So if we were to use algebra tiles, those are all the like teal, green, and yellow things on the screen. So we have one x squared tile and we have four x tiles. So we have four tiles that have a label X on it, right? And we talked about geometrically how a square has the same length and width. So if we already have a square as a tile that's called X squared, then we're going to add a tile to the right of it, that's an X. We're going to add a tile to the bottom of it, that's also an X. And we're going to add another one and another one so that we have a total of four rectangular X tiles, okay? So when we try to find C, what's happening geometrically is we're trying to figure out what goes in this space. How many squares, little squares that have a square unit of 1. So how many of those can we fit in there? We can fit 1, 2, 3, and 4. So in this example, my C would equal 4. So in order to complete this square, to finish this expression, we would have to add 4 where this C is. So we would have to say x squared plus 4x plus 4 is equal to 0 in order to keep solving. Let's look at another one. So now we have this expression x squared plus 6x plus some c. We need to figure out what that c is, or we need to complete the square. So we have an x squared tile. We have 6x. We have 6 tiles that are labeled x. So here's 1, here's 2, 3, 4, 5. I'm just dragging these. 6, and now we have to figure out what can fit in that leftover space. How many of those little 1 square unit yellow boxes can fit in there, and that's going to be my C. So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So my C is all these little yellow tiles, the total that we have, which is 9. So in order to complete my expression, or to complete the square, if you will, I need to fill in where C would be with a 9, because we had 9 square unit yellow tiles. So just to recap, why do we call it finding C? Because when we complete the square, we ultimately need to figure out what number replaces this C in my generic form. But you guys, the last two examples we did in order to find C, in order to complete the square, was we actually had algebra tiles as a visual to see what portion of the actual physical geometrical square that we had to complete. So when we don't have algebra tiles, and if you can't visualize that in your head, we're obviously in algebra going to need a formula, right? So the formula, it's not really a formula, but the helpful like hint or formula, whatever you want to call, for C, or to find C in this generic form, would be taking the middle number b, so whatever number is paired with x, whatever number is in front of your regular x term, divide it by 2 and square it. So C is the value of C, that C right there is going to be equal to b divided by 2 and then squared. Let's look at an example. So these are the 4 examples that I want you to write into your notebook. So you didn't have to write anything in your notebook until this slide. So let's do these 4 examples. So if we're going to use the b divided by 2 squared formula, our b in this example is 10. So we would say 10 divided by 2 is 5, and then we need that thing squared, which is 25. So that's what goes in this blank, or in my C. This whole column is going to be your C value, or the number that you need to find in order to complete the square. So I want you guys, before you come back to class tomorrow, I want you to try to find C on the last 3 problems. And I'm going to be checking your notebooks when you come into class the next time I see you. So make sure you get all 4 of these examples in your notes, and I'm definitely going to check those last 3. Thank you all for listening, and I shall see you soon.